Hello everyone and welcome to today's video. So over the past few weeks, Meta AI's general purpose image segmentation model has attracted a lot of attention. The model SAM, or Segment Anything Model, is available under a permissive open license, Apache 2.0, and it was trained on a dataset consisting of 11 million images and over a billion segmentation masks. So SAM is very powerful, and according to Meta, it has learned a general notion of what objects are, and it can generate masks for any object in any image or any video, even including the objects and image types that it had not encountered during training. So SAM is general enough to cover a broad set of use cases and can be used out of the box on new image domains without requiring additional training. So this is a capability that is often referred to as zero-shot transfer. So today we are going to deep dive into one such unique use case and see how we can achieve instant segmentation using SAM. So I have my colleague here, Soham. Soham, do you want to explain what our use case is?
Yeah, sure. So here we'll dive deep into floor plan room segmentation using Meta's cutting-edge segment anything model. And in this tutorial, we'll walk you through the entire process step by step, focusing primarily on the code part. Before we start, I would like to talk about our problem statement. So our focus in this blog is on the application of instant segmentation to the floor plan images that we have here. So on the left side, if you see here, we have the floor plan image of a architecture plan. So floor plans are typically used in architecture and real estate, and they represent the layout and structure of the buildings or the properties. And extracting room segment from floor plan images is crucial for various purposes, such as interior designing, property appraisal, and architectural planning. So the main use case here is about instant segmentation. So instant segmentation is a powerful computer vision task that combines object detection and semantic segmentation, and it's used to identify and distinguish individual objects within an image at pixel level. So this technique has numerous applications, and today we are focusing on the unique challenge of extracting room segments from the floor plan images.
Okay, yeah, that sounds very exciting. There's one question that comes to my mind though, like there are other segment models available, right? For example, there is YOLO V8, which is smaller, it's faster and also efficient. So could we have used YOLO V8 for this use case, or are there any limitations with YOLO V8 that we are trying to address with SAM?
Yes. So initially we did try out the YOLO V8 approach. So YOLO V8 as an object detection model is not specifically designed for room level instant segmentation. So adapting it to this specific task would require substantial modification and fine tuning of the model. YOLO V8 requires large and diverse dataset for effective training in tasks like floor plan instant segmentation. But such datasets specifically designed for these purposes are rare. So, and even if you find these datasets, annotating floor plan images for YOLO V8 training is a challenging task due to the need for detailed annotations that specifically specify room locations and distinguish between instances of the same room type. So this is a very labor-intensive task, and there's a lot of error-prone availability here. So it's a very difficult task. Okay. And this is where SAM outperforms. So since it's trained on a very large data set, it excels on the pixel level segmentation, and this makes a perfect choice for floor plan instant segmentation.
Oh, okay, yeah, that makes sense. So let's do a quick demo and walk through the code.
Sure. So let's start that. Okay, so before we dive deep into the code part, we'll first start with installing the segment anything package. So here, they have already made it available on the PyPy package list. So you just install it using the pip library, and you just say use the command pip install segment dash anything, and it will install the segment anything library. Next, once we have installed the SAM library, then we can go ahead and import the other required libraries. These are mainly for loading the images and plotting and visualizing the results. So, for example, we are using OpenCV and PillImage and like matplotlib to display the results. The main library is segment anything library, from which we are importing SAM model registry and SAM automatic mask generator. So let's see how we use these libraries and do the inferencing. So the first step is to download the SAM weights. So using this weights, we'll be able to load the pre-trained model. So to download the weights, they have given us a URL from where we can directly download the weights, or you can like use this code snippet to download the weights and store it in a desired destination path. So once we have downloaded the weights, we move ahead to load the SAM model. So to load the SAM model, we will be using SAM model registry, which we have imported from the segment anything package. So here we mainly define the model type that we want to load and the checkpoints that we just downloaded, the path to the checkpoints. So using the model registry, make sure you have downloaded the model paths that go along with the model type that you're using. So here we are using VITH, which is the default model type that they have, where they're using the vision transformers. And we have downloaded the same model checkpoints for that particular model type. So once we load the model from the model registry, we upload it to the device. So we shift the model to the CUDA device. If CUDA device is not available, you can also run the inference on CPU, but it will just take a bit longer. So once the model is loaded, we move ahead and load the image and process it a bit. So for loading the image, we are using PIL package, and we load the image in RGB format. And once the image is loaded, we resize the image to a particular dimension size. So here we just like set the image path, load the image, and resize the image to a particular max dimension. So this resizing is required because if the image size is like too large, then while inferencing, the SAM model could go out of memory. That's why we restrict the image size to a certain dimension. And so once the image is resized, we convert the image into a NumPy array. So this is how the initial floor plan image looks like after loading and resizing. So once this is ready, we can pass this image onto the SAM model and do the inferencing. So for the inferencing part, we have the main function as get SAM mask, which will return the predicted segmentation mask that we generate. So for this, we have to initialize the SAM automatic mask generator. So here to initialize this, we are using certain parameters. You can also skip these parameters and initialize it with the default settings. But we found out that using these parameters give a fine-tuned output and better segmentation masks. So you could like learn more about these parameters in their GitHub repo. But mainly these particularly for the floor plan instance segmentation, the one parameter that really improved the output was crop and layers. So what this does is, So what this parameter does is, it reperforms the mask prediction on the crops of images that are available. So it iterates on the crops of images, producing more finer masks. So once this mask generator is initialized, we can simply call the .generate method on the mask generator, on the image to it, and it returns the predicted masks. This function is just to display the predicted mask, which basically simply uses matplotlib. So once we have the mask, we can simply visualize them, and this is how the output looks like. So here I'll just zoom out a bit. So here in this floor plan image, you can see you have the overall room segments, and every room segment is separated out from the floor plan, and that's how the final output should look like. So in conclusion, SAM is a game changer for floor plan room segmentation. Its extensive training data and adaptability make it ideal choice for this task. So by following this step, we outlined in this video, professionals in architecture and real estate could really take advantage of this model.
Absolutely. Yeah, that was a very interesting use case, Soham. And thank you for this demo. So, yeah, SAM really is very powerful and versatile, and it can be used for a multitude of downstream tasks. Like you mentioned, whether it's for architecture professional, real estate, interior designs, basically the
Yes.
tasks that can go beyond its training data, right? And it may include like edge detection, object proposal generation, instance segmentation, and so on, right? One thing I would like to note though, so while SAM has shown an incredible amount of flexibility in its ability to segment over wide ranging image modalities and problem spaces, SAM was released without the fine tuning functionality out of the box. So, in our next video, we are going to walk you step by step through SAM fine tuning process. So, stay tuned for that. Also, watch out for the blog on this very solution that we just demonstrated. Once it is published, I'll be posting the link in the description below. So, thank you for watching and reach out to us with any question, comments, or feedback. Thank you.
Thank you.